Alright, Tsebang, you have asked for me to do the nature of roots. Okay, so very quickly, nature of roots. First and foremost, what is a root? If I gave you an equation, x squared minus 4 is equal to 0, okay, let's say I said solve for x. Alright, x squared minus 4 is equal to 0. So the expression here is a difference of two squares. So what you would do is you open two brackets, and the grade 10 learner will tell you, Tsepang, that when you factorize a difference of two squares, you take the square root of the first term, which leaves you with x. So you put x as your first term in each bracket, because the square root of x squared is x. Then you take the square root of the last term, which is 4. So that is 2 and 2. In other words, square root of 4 is 2. So you write 2 and 2 in the bracket. And this minus sign means you have two different signs inside the bracket. So you have x plus 2 into x minus 2 is equal to 0. This is basically us factorizing x squared minus 4 to give us x plus 2 into x minus 2. Then we use something called the zero factor law. The zero factor law says if there are two factors multiplied to each other equated to 0, then each respective factor can be equated to 0, which then leads to the respective solutions. We transpose the plus 2 over to the other side, we get x is equal to minus 2. We transpose the minus 2 to the other side, we get x is equal to 2. We call these are what we call roots. Okay, these are roots. Okay, so I need you to understand that fundamentally, when we talk about the nature of the roots, we are basically in essence saying what are these solutions, because x is equal to minus 2 and x is equal to 2 are what we refer to as the roots. Okay, these are also called x-intercepts. So roots are what we refer to as x-intercepts. And under the topic inequalities, roots are also called critical values. Okay, I need you to understand that roots are these solutions, x is equal to minus 2 and x is equal to 2. Those are roots. We also refer to these as x-intercepts. Why? Because when we let y is equal to 0, we actually find x-intercepts according to functions from last year. These are also called critical values, because when you do inequalities and you're solving for inequalities, you usually find what we refer to as critical values. So these three things, roots, x-intercepts, critical values, are different ways to refer to these things under various topics. If we are talking about quadratic equations, we call them roots. If we're talking about functions, we call them x-intercepts. If we're talking about inequalities, we refer to these as critical values. Okay, that was just to enlighten you a little bit more about these two solutions. Now, these roots, you can comment about these roots under three things. One, are these real or non-real? In other words, are these real numbers? The two solutions that you see there, are they real numbers or non-real numbers? So minus 2 and 2, are these two numbers real or non-real? 2, you need to also comment on whether those roots are rational or irrational. Okay, and then 3, you need to comment as to whether these roots are equal. In other words, are they the same or unequal? In other words, are they not the same? All right. So this is just me trying to sort of like help you understand that Roots are solutions of a particular equation. So this is a quadratic equation. So these solutions are what we refer to as roots. And basically, if I'm asking you what is the nature of the roots, I'm basically asking you under these three subheadings, are these roots real numbers or are they non-real numbers? Now I can tell you straight out that the nature of these two numbers, in other words, the nature of 2 and negative 2. 1. Are these two numbers real or non-real? Negative 2 and 2. What are real numbers? Real numbers are basically all the numbers in a number system. Alright? And they include both rational and irrational numbers. So basically, minus 2 and negative 2, the two numbers themselves, which are the roots, are they real or non-real? Okay, so I'm hoping the person who asked the question, for instance, could answer me. What's a pang Dinzi? She's still here. Sebang is gone. Oh, you asked the question. Okay, they are real. Very good. They are real numbers. Very good. Thank you, Tsapang. 2. Are the numbers, these two numbers, minus 2 and 2, are they rational or irrational? Do you still remember what rational numbers are? We say rational numbers are numbers that can be written in the form A over B, where A and B are actually what? Integers. Okay, integers are positive and negative whole numbers, and where the denominator, meaning B, can never be 0, because if there's a 0 denominator for a fraction, we know that the fraction is undefined. When we look at decimal numbers of rational numbers, they can be one of two things. They can either be terminating numbers. In other words, if you write a decimal, it will be 0.75, stop. It doesn't go on forever. 0.2, stop. Doesn't go on forever. 0.987, stop. Doesn't go on forever. So these are terminating decimal. Okay, terminating. The word terminate means to stop, cut, end. So basically the numbers cut, stop, end. Either second decimal, it ends. First decimal, it ends. Third decimal, it ends. It could be fourth, it could be fifth, it could be sixth. Basically, they come to an end. Those are terminating decimals. These are all types of rational numbers. Or they can fall under a second category, which is recurring decimals. Recurring decimals are like numbers that have a repeating digit after the comma. It's either a single digit repeats, and you usually see the symbol. You'll see a horizontal line above the number that repeats, or you could see dots above the numbers that repeat. Okay, because there's a repetition of a single number, maybe two numbers, it could be three numbers, but it repeats. There's an infinite recurring decimal, in other words. So these categories of numbers, they both fall under what we call rational numbers. Okay, irrational are the opposite of rational. In other words, they are non-terminating and they are non-recurring. So they are not exhibiting the same qualities as rational numbers. And then lastly, like I said, the roots, are they equal or unequal? Meaning, are they the same or not the same? So if I go back to my comment, remember what I said. I said these are roots, minus 2 and 2. Are these two numbers, are they real or non-real? So Tsapang said they are real. 2. Are these two numbers rational or irrational? Tsapang. Minus 2 and 2, are they rational or irrational? Tsapang, do you know? Remember what I said, a rational number can be written as a fraction. Okay, Ed says they are rational. Yeah, I just hope Sapang is here because she asked the question. You know, when you are answering someone's question and then they are not here, it kills the whole mission and purpose of answering that question. Okay, yes, guys. 2 and negative 2 are both rational numbers. Okay, 2 and negative 2 are both rational numbers. And then lastly, 2 and negative 2, are they equal or unequal? In other words, are they the same or unequal, meaning are they not the same? So obviously 2 and negative 2, guys, are unequal. Okay, right? Yes, Tsepang, they are rational because we can represent them as 2 over 1, and negative 2 we can represent as negative 2 over 1. And then lastly, they are unequal because they are not the same. So Tsepang, what I've just done is we have just determined the nature of roots by solving the equation. That's what we've just done. By solving the equation, getting the roots, we've then commented on the roots, the fact that minus 2 and 2 are real, minus 2 and 2 are rational, minus 2 and 2 are unequal. But when you do discuss the nature of roots or determine the nature of roots, there is a way that we can do this without solving the equation, right? And that way that we can discuss or determine the nature of roots without solving the equation actually comes from this part. Do you know what this is? What is this? X is equal to minus b plus minus the square root of b squared minus 4ac over 2a. What is this, guys? Do you know what this is? Tell me what that is, and I will end this live right now. Okay, Tsepang, you just told me what this is, so I have to actually end the live. I have to end it, unfortunately. Okay, Asake, this is definitely not a quadrilateral, okay? But it is a quadratic formula. Thank you very much for actually saying so, Tsepang. Alright? No, I'm just kidding, Tsepang. Definitely wouldn't. I just wanted to shock everybody into hysteria. Okay, so yes, this is the quadratic formula. So, no, you heard me. You heard me very well. You heard me very well. I was just joking. Okay, so this is the quadratic formula. So we can utilize this section. This here, underneath the square root, we have here something that we refer to as the discriminant. Okay, and the discriminant, okay, the symbol that we use for the discriminant is this here, when we refer to it as the Greek alphabet letter delta. Okay, this is a symbol that refers to a delta, which is a Greek alphabet. So delta, right? Yeah, and then delta is basically the expression b squared minus 4ac. This helps us to be able to decipher and determine what the nature of the roots is without actually having to go the route of solving the equation. All right, we can actually use this discriminant, okay, the expression b squared minus 4ac, which is apparently located underneath a square root. We can utilize that to be able to discuss the nature of roots. How do we go about that? There is a method, and the method to discuss or determine the nature of roots without solving the equation simply is the following. One, we need to make sure that a given equation that we have is written in standard form. That is the first step. Step number one. We need to make sure the equation that is given to us is in standard form. Then step number two, we need to identify our A value, our B value, and our C value. A value, remember, standard form of a quadratic equation is ax squared plus bx plus c is equal to 0. So our a value is simply the coefficient of x squared, the number before x squared. B value is the coefficient of x. The c value is our constant term. All right. Okay. So when we have the equation in standard form, we can easily identify the value of a, b, c. Okay. 3. We write down the discriminant, which is equal to b squared minus 4ac, which is delta. 4. We substitute in delta our a, b, and c in brackets, the values of a, b, and c in brackets. 5. We get the value of delta and comment. All right, and we comment on it. So with this method, guys, 1, write the equation in standard form. 2, identify our value a, b, and c, meaning the coefficient of x squared, the coefficient of x, the constant term. C, we write down, number 3, the discriminant or delta is equal to b squared minus 4ac. 4, we substitute in this discriminant a, b, and c using brackets. Okay, please. And then 5, we get the value of delta and we comment on the roots based on the value of the discriminant. We comment on the roots on the basis of the value of delta that we get. So I'm going to do a classic example so that I can show you guys how you can do this. So let's say we are given the equation x squared minus 4 is equal to 0, as we had basically went ahead. We actually solved, we got the nature of roots with solving the equation, remember, initially. So I want to now use the discriminant so that we can actually determine the nature of roots without solving the equation. And remember, the minute they say without solving the equation, in actual fact, if they say determine or discuss the nature of roots, we always take it that the simplistic way is to basically use the discriminant. Okay, so first and foremost, x squared minus 4 is equal to 0. This is already in standard form. So step number 1 is already done. This is already in standard form. Step number 2, we need to identify a, our b value, our c value. Okay, so if we look at this, our a value, remember our a value is the coefficient of the x squared term. Oh my soul, what is happening here? The coefficient of the x squared term. What is the coefficient of the x squared term here? Our a value. A is equal to, can we see it? A is equal to, anytime now, 1, thank you Neliwe and Lesedi. B is equal to, anytime now, do we have an x term, by the way? Do we have a middle term? So B is equal to, okay, anytime now, it's coming, don't worry, these guys are, they've got their, remember B, guys, B, not C, B. Neliwe, I'm looking for B. What is the value of B? No, Neliwe, B is not negative 4. Thank you, Desperado. Desperado, B is equal to 0. Remember, there is no middle term here. This is x squared minus 4. I have my a, the coefficient of x squared. B, remember, comes from the coefficient of the x term. There is no x term here. So that basically means that our b value is 0 because there's no x term. The coefficient should definitely be 0. Okay. Then C, our constant term, is equal to, I think nearly when now you are in the place to answer what you had answered initially. Our C value is equal to, yes guys, it's negative 4. Spot on. So there it is. A is equal to 1, B is equal to 0, C is equal to negative 4. Step number 3, write down the discriminant. B squared is equal to, delta is equal to b squared minus 4ac. Next step, we substitute using brackets. So b is 0 and then we square it. in brackets, you see, minus 4a is equal to 1 in brackets. C is equal to negative 4 in brackets. Why in brackets? Because guys, brackets mean multiply, and this is the relationship that exists between 4a and c. B squared, obviously, we need to put 0 in brackets so that we ensure that we are doing that. This is grade 11. 0 minus, remember, negative times a positive times a negative gives me a positive. Positive what? Positive 16, because 4 times 1 times 4 is 16. 0 plus 16 is 16. So delta is equal to 16. Now, before we comment on the roots, all right, we need to make certain conclusions about delta. Delta is equal to 16. So that means what? It means delta is greater than 0. Guys, this is such a big thing to actually state shortly after you have found the value of delta. Delta is equal to 16, and obviously this value is a value that is greater than 0. That's the first thing. Additionally, delta is a perfect square number. Okay, yes or Vio, it's because 16 is greater than 0. Very true. Houdini. Also, additionally, which is very important, delta is a perfect square. Guys, if you state these two things, they actually assist you to then comment on the roots. Okay, you need to say something about delta either being greater than 0, less than 0, or in the case where this is a value equal to 0, you write delta is equal to 0. Then additionally, please say something about the value of delta as to whether it is a perfect square, if it is, or if it is not a perfect square, you state that fact. Now you are going to ask why. Why, Minier, do I need to write these two things about delta? This is why. You then comment on under three things, Mos. Whether the roots are real or non-real. Remember, now you can say roots are real. Do you know why you say roots are real, guys? It has everything to do with being greater than 0. Delta being greater than 0 means roots are real. So that is why greater than 0 is important to say delta is greater than 0, because you can say the roots are real. 2. Rational or irrational. You can say the roots are rational. That has everything to do with delta being a perfect square. And then lastly, unequal. Sorry, I said real here, repeating this thing. Roots are unequal. That has everything to do with the fact that delta is greater than 0. So I hope that makes sense. Okay. Done. Finished. That is how you determine or discuss the nature of roots without solving the equation. Step 1, standard form. Step 2, identify A, B, and C. Step 3, write down delta. Step 4, substitute using brackets. Step 5, determine the value of delta. Step 6, you say something about delta. About it being greater than 0, you state it if that's the case. If it was equal to 0, you'd say delta is equal to 0. If it's less than 0, you'd say delta is less than 0. Then say something about it being a perfect square or not. And then lastly, you comment on the roots, on the basis of these two things here. That's it. I want to do one last more. I'm going to repeat them even through this one. Let's say just hang on. I'll repeat it again. Okay. X squared plus x plus 1 is equal to 0. So step number 1, you need to make sure the equation is in standard form. Okay. Okay, I don't know what's happening here. Focus. Standard form. In other words, ax squared plus bx plus c. Okay, if there are things on this side, you transpose them so that the equation is standard form. 2, you identify a, b, c. A, 1, b, 1, c, 1. A is equal to 1, the coefficient of x squared. B is equal to positive 1, the coefficient of x. C is equal to 1, the constant term. Step number 3, you write down delta is equal to b squared minus 4, the discriminant. Alright? Next, you substitute. B is 1. A is 1. C is 1. Then you simplify. 1 minus 4 times 1 times 1 is negative 4. 1 minus 4 is negative 3. Delta is equal to negative 3. Then you state the obvious about delta. Delta is less than 0. In other words, because this is a negative value, negative 3 is a value that's less than 0. So delta is less than 0. Okay. Good evening, ma'am. Good evening. Good evening. Okay. And because delta is less than 0, remember, this being a negative value, all right, it means that the roots are non-real. And they are non-real, full stop. We can't say anything further, right? Something that you must note now about the fact that we say that the roots are non-real, okay? It means that there are no real roots. In other words, if we were solving this particular equation, we would find that there is no solution. There are no x-intercepts. There are no x-intercepts, there are no critical values. In other words, if there are no solutions, if there are no x values, how can we possibly go ahead and say something about something about something that does not exist? It's not there. We can't go ahead and say they are unequal or equal, because remember, these are roots that do not exist. They are imaginary. All right, imaginary numbers. So understand that whenever you say non-real is just non-real. It means there are no real roots. There are no x values. There are no x-intercepts. There are no critical values. Basically, we cannot comment further about something that does not exist. So roots are non-real. All right. So when delta is less than 0, guys, we can only make this conclusion, full stop, and we cannot say anything more under the 2 other additional subtopics. Okay, because remember, we usually would say something about them being rational or irrational, and then we'd say something about them being equal or unequal. But because here the roots are non-real, these are roots that do not exist. So we cannot say anything more than just the roots are non-real. This means that there are no real roots. So we can't say there are rational or irrational. We can't therefore further say they are equal or unequal because those roots don't exist. So hopefully you understand. So for the benefit of the learner that asked, should I ask me to repeat? Remember, when you are asked to determine the nature of roots without solving the equation, they are simply asking us to use the discriminant to describe the nature of roots. So the step that we need to follow, we should remember. Step number 1, write the equation in standard form. This is standard form. Okay. Step number 2, you identify the A, the B, and the C. Step number 3, you write down the equation. We write down the expression of delta. Delta is equal to b squared minus 4. You see, you substitute A, B, and C in the place of A, B, and C in delta. You work out the value of delta, and then you say something about delta based on this value. If the value is greater than 0, is greater than 0, then you state that delta is greater than 0, and you check if this value is a perfect square. If it wasn't a perfect square, then you'd say delta is not a perfect square. Okay, right. I just wanted to say the following, and maybe just as a sort of like a conclusion. If you find as you work it out, you get to a place where it says delta is equal to 0. Are you with me? If you get to a place where it says delta is equal to 0, then remember that means delta is equal to 0. It means delta is a perfect square. Then what would you say? You would say roots are. Remember, if it's equal to 0, it still means roots are real. 2, rational or irrational. Remember, if it's a perfect square, it means the roots are rational. And then last but not least, if delta is equal to 0, it means the roots are equal. Okay, so what? The only time you will have roots that are equal is if delta is equal to 0, guys. Okay, perfect square will always mean rational roots. If delta is a perfect square, it means the roots are rational. And then of course, if delta is equal to 0, we still mean the roots are real. Just like if delta is greater than 0, the roots are also real. Okay? But when delta is less than 0, then obviously the roots are non-real, full stop, because there are no real roots that actually exist. Okay? Okay. I think whilst I'm still on this point, I want to make this last point. Let's say you worked out, you followed all the steps, and then you get to a place where it says delta is equal to 17. Then what are you going to say? You're going to say delta is greater than 0, and you're going to say delta is not a perfect square. I'm just going to write PS for short, meaning perfect square. Okay, hope you guys get it. So delta is greater than 0, you would say, and you'd say delta is not a perfect square. Are you with me? Then what would you say about the roots? The roots are real. 2, rational or irrational. If delta is not a perfect square, what does it mean about them being rational or irrational? Do we say rational or do we say irrational? What do you guys say? Thank you, Lesed. Lesed is like participating full on. And then last but not least, equal or unequal if delta is equal to 17. Ovayo, thank you so much. Yes, definitely the roots are unequal. Okay, because remember, the roots are only ever equal if delta is equal to 0. Okay, guys, I hope you get the point. As long as we're following the steps, write the equation in standard form. Someone was asking earlier on, how is it that b is equal to 0, but we say c is negative 4? Guys, please understand, ax squared plus bx plus c is equal to 0. Our a value comes from the coefficient of x squared. Our b value comes from the coefficient of x. So you can see there's no x term here. So that means our b value is 0. Please, guys, right? And then our c value is negative 4. Remember, when we write down the constant term, in fact, every time we write down these things, we consider the sign of the coefficient as well. We don't just write down the coefficient, we consider the sign as well, and we put it there. So C here is negative 4. Okay. Hopefully now you are clarified, those people that had all of these questions, and we are fine. The other last thing I want to just touch on for those who are here, just whilst we are still on nature of roots, there's a second type of question. The questions that I've just done are type 1 of nature of roots. Nature of roots, we can ask people to discuss the nature of roots. There are these questions that go like this: for which values of k are the roots? So you get a particular equation for which values of, let's say, of k are the roots of x squared minus 3x is equal to p. 1 real, 2 non-real, 3 equal, 4 maybe they can say real and unequal. So I just want us to walk through this. They are asking us for which values of let's just be consistent here. Let's say they say for which values of p are the roots of x squared minus 3x. Okay, sorry about the blurriness. I don't know, guys. This I don't know. You could swear like something happens. For which values of p are the roots of x squared minus 3x is equal to p real? Okay. For which values of p are the roots of x squared minus 3x equal to p real? So in other words, they want us to find the value of p that we can have here, that will make the roots of this particular equation to be real roots. Okay, so we need to calculate these values of p and get them. So the way we go about these types of questions, because I call these type 2 nature of roots questions, type 2. And what you need to do here is method. Let's look at the method. Step number 1, we need to write the equation in standard form. And I always insist that your a value must be a positive a value to be a real standard form. True standard form. Positive a reflects, if the coefficient of x squared is positive, it reflects true standard form. I mean, you can never really say something is truly happy if it's positive, right? So I don't want any negativity in the mix. So standard form. Step number 2, we need to identify a, b, and c from that standard form. And then 3, we need to set up an equation, or it can be an inequality based on the condition. Now you are asking probably like, what does this person, the condition of the roots? Now some of you may be asking, what do you mean set up an equation or inequality based on the condition of the roots? And there are 3 types or 4 types of in fact, you can either set up a linear equation, or it can be a linear inequality, or 2, you can set up a quadratic equation, or it can be a quadratic inequality. So when you set up here, it's one of 4 of these that you will eventually be having to solve. It's either you're going to be solving a linear equation, and a linear equation was solved very nicely in grade 8, in grade 9, in grade 10, So you are in grade 11, you have literally 3 years of experience solving a linear equation. A linear inequality, you only solved a linear inequality in grade 10. So you actually have a year of experience solving a linear inequality. Or 2, you could either be solving a quadratic equation. You've solved a quadratic equation since grade 9. You have grade 9, grade 10, you're now in 11, so you have 2 years of experience solving a quadratic equation. Or you can solve a quadratic inequality. You only have a few days of having learned how to solve a quadratic inequality, but surely the method now is starting to really sink in. So it's one of 4 of these. After setting up that equation, you are going to be solving one of 4 of these. And step number 4, after setting up an equation and setting it up to be as such, you solve for that unknown value. Okay, whatever it is. If it's a linear equation, you get that particular unknown value. If it's a linear inequality, you get that interval of values that will satisfy the equation. If you get a quadratic equation, you solve for that unknown. If you get a quadratic inequality, you must make sure that you follow that method of solving for a quadratic inequality the way that you've been taught here in grade 11. There are steps that you follow whenever you are solving a quadratic inequality, so, and so forth. So you need to still use those very same steps that you utilize. So let's go here. Let's go and apply what we've just mentioned as the method of solving these types of nature of roots questions. So I repeat, the question says, for which values of p are the roots of x squared minus 3x is equal to p1 real? Right, so we are going to first look at this condition of the roots, which is real. So step number 1, write the equation in standard form. There is our equation. Let's write it down. X squared minus 3x is equal to p. That is not in standard form yet, so let's make it to be in standard form. X squared minus 3x, we transpose them p, we get negative p is equal to 0. This is standard form, guys. Our coefficient of a is positive. That's exactly what we want for our standard form. So this is true standard form. Step number 1 is done and dusted. Step number 2, identify a, b, and c. A is equal to, b is equal to, c is equal to. Let me see in the comment section if people are still with me. What is the value of a, guys? And b and c. You can write them down, all of them, all 3. Okay, let's say an angel says 1. I guess they all commenting about a. You guys are spot on. Now let's just get b and c as well. You can just write b is equal to and then c is equal to, so that I can have all of them. Let's say I see you're saying negative 3. For what? Okay, please write the letter as well. Write b is equal to, c is equal to, so that I can know for sure if you're getting the a and the b value. So a is 1, I get that, that's standard. Okay, the value of b, okay, guessing let's say you were saying for b it's negative 3. Okay, you are right. What is c though? So a is 1, b is negative 3. What's c? Okay, let's say this says c is equal to 0. No, c is not equal to 0. That's not true. Anyone else who is listening, who wants to dare try? C is not negative 1, definitely not. C is not negative b, no, because there's no b here. This is the letter p. Oh, thank you, Stoic. So that means c is negative p, thank you. C is negative p. No, Stoic, it's not quadratic formula. We're not busy with quadratic formula. We're busy with the discriminant here, right? And we are looking at the question that says, for which values of p are the roots of x squared minus 3x is equal to p real? Okay. So we've just written the equation in standard form, which was step number 1. Step number 2, we identify a, b, and c. A is equal to 1, b is equal to negative 3, and c is equal to negative p. Please guys, understand that the reason why the constant is negative p, I know some of you are like, but why is c not negative 1, sir? Because don't we write down the coefficient? Remember guys, I said a is the coefficient of the x squared term. So that means x squared, we do not put x squared in the mix when we write the value of a. We just use x squared to identify where the coefficient of a exists, okay? And everything around x squared should then be written as the coefficient, all right? So in this case, it's 1. The x term, the coefficient of the x term will give us the value of b. And then everything that is not x, that is another letter, that is not x, will be written as, that is basically on its own, will be written as our constant term. So negative p is our constant term. Remember, we wanted to find out for which values of p. How will we be able to solve for p if p is not in the mix amongst a, b, or c? All right. Then, step number 3, we said we set up an equation or inequality based on the condition of the roots. Now, I want you to listen to me in this one. When we say the roots are real, what does that mean for delta? For real roots, what can that mean for delta? Delta is what? It's greater than 0. We know that when delta is greater than 0, the roots are real. But as well as when delta is equal to 0, the roots are also real. So that's why when we set up our equation, the condition of real roots means that delta is greater than, but also or equal to 0. So we say delta is greater than or equal to 0 for real roots. Then b squared minus 4ac, which is delta, is greater than or equal to 0. So you see guys how we are going to set up, and in this case it is an inequality, but the question is it a linear inequality or will it be a quadratic inequality, because we've got an inequality sign in the mix. So b is negative 3. Now we can substitute so that our equation can be set up. Negative 3 squared minus 4a is 1. C is negative p greater than or equal to 0. This is grade 11, Babes forever. Okay, so b, negative 3, substitute with brackets. Negative 4, a is positive 1. C is negative p greater than or equal to 0. Then we can continue. Minus 3 squared is 9, positive 9 that is. Minus 4 times 1 times negative p. What's negative times a positive times a negative? That gives us a positive. 4 times 1 times p, 4p greater than or equal to what? 0. Does that make sense? Then last and final step, we are solving what type of inequality? It's a linear inequality. It's the grade 10 type of inequality. So this one is straightforward, the grade 10 type inequality. All we do is we transpose the 9, we get negative 9 on the other side, then we divide both sides by the coefficient of p, all right, which is 4. We get a value of p is greater than or equal to negative 9 over 4. That is it. We are done. With this linear inequality, we were able to discover that if p can be equal to negative 9 over 4, or if it can be a value that is more than 9 over 4, it will forever ensure that when we determine the nature of roots, the roots are actually what? They are real. So when they are asking for which values of p are the roots of this equation real, then it's pretty obvious that it's when p is equal to negative 9 over 4 or when p is slightly above or more than negative 9 over 4. So this is how, guys, you would approach these questions. They are called the for which values. You are actually trying to find the unknown other letter variable by using a particular condition based on the roots. So if I was answering number 2, the only thing that will change is that I will rewrite this in standard form again, identify A, B, and C. Then I would ask for non-real roots, how is delta? So here I would set up an inequality that has delta is what? Less than 0. Then I would solve my inequality again, all right, where delta is what? Less than 0, by using this condition. For number 3, they say for which values of p are the roots of this equal. So I would set up an equation, because remember, for equal roots, it's when delta is equal to 0. So I would set up another equation where delta is equal to 0. Write it in standard form, identify A, B, and C, set up an equation using my condition again, substitute, solve the equation, get my value of p. All right. Then last but not least, when it says for real and unequal roots, that means delta, remember, when it's real, it means delta is greater than or equal to 0, but they are saying real and unequal. So that means I can't put equal there, because they are only saying delta. They are saying for roots that are real and unequal. So now I have to just say my condition when I set up my inequality will be delta is greater than 0. Repeat the same process, write the equation in standard form, identify A, B, and C, and my new condition would be when delta is greater than 0. I substitute and I solve my inequality where delta is greater than 0. So these questions, guys, I call them type 2, the for which values of p type questions. Okay. And type 2 has type 2.1, which I'm just briefly going to touch on, and that will basically be it, guys, for nature of roots. So I'm hoping Utsabang, who was here, was it Utsabang, yeah, that you have given you a little bit more than what you asked for, but then it was hopefully beneficial to you, Utsabang things. So type 2.1 of those types of questions, which are for which values, is when you are actually given, let's say they say x is equal to minus 3 plus minus p squared minus 9 over 2. So they tell you that the roots are given. The roots are given. X is equal to minus 3 plus minus p square root of p squared minus 9 over 2. And then they say for which values of p are the roots. And I'm just going to say 1, non-real. Okay. They could write other ones like the ones that I've listed here, and all you need to do is be able to set up the equation, obviously, or whatever. Okay, look at this. So this time round for type 2.1, they didn't give you an equation. Okay, they have given you actual roots. X is equal to minus 3 plus minus the square root of p squared minus 9 over 2. And then the question that they're asking is, for which values of p are the roots non-real? Okay. So for type 2.1, the method is like this. Okay, I'm just going to quickly write it. Type 2.1, what's nice about it is that you are just given roots, and the simple method is that 1, go and take delta under the square root. Go and take delta under the square root. 2. Set up equation using condition and solve. Set up equation using condition and solve for unknown. I hope you guys can see what I am talking about. So I'm saying go and take delta under the square root. Please remember what I said earlier on when I started. The discriminant b squared minus 4ac, which we use and we refer to as delta, is situated under a what? A square root. Okay, and this is the quadratic formula which I usually use when I cannot solve for x and factorization is not possible. I use this quadratic formula. But under the square root, this is basically the expression I'm always using to be able to do what? To determine or discuss the nature of roots. To sort of like, be able to decipher and determine what is the nature of the roots. I use the discriminant, the expression under the square root. So now, in this particular question, the roots are given, and as they are given, I am given the expression under the square root which represents the discriminant. So delta is actually this expression, which is why it says for which values of p are the roots what? Non-real. Guys, if you have any questions, please do ask in the comment section. If there's something that's not amiss, that's not clear for you, please let me know. So this type of question is still under type 2, but I call it type 2.1. Why? Because it is a slightly different type of question, because unlike type 2 where you were asked for which values of p and you were given the equation, all right, and then you had to go and actually write the equation in standard form, write a, b, and c, then substitute in delta so that you can set up with the condition and then solve for the unknown. Here in this one, you actually have the roots, not the equation. And underneath this square root, this is where b squared minus 4ac would be. That means this is delta. So all you do for this method, you go and take square root, the delta under the square root, and you set up an equation using the condition and you solve for the unknown. So step 1, where do we start? We first determine, when we say non-real roots, what do we mean about delta? Do you remember what we mean about delta when we say non-real roots? Do we still remember, guys? What do we say about delta when the roots are non-real? Delta is yes, thank you, Tsepang. It's when delta is less than 0. So that means we are going to be setting up, okay, an inequality where delta is less than 0. So that means we go and fetch the discriminant, which is p squared minus 9, and we just simply say delta less than 0, b squared minus 4ac less than 0. In other words, delta here, or b squared minus 4ac, is represented by p squared minus 9 less than 0. Then we are going to solve this thing here. This is not a linear inequality, it is a quadratic what? Inequality. So that means I'm going to use my grade 11 method of solving a quadratic inequality and nothing less than that. Okay, so this is my standard form. Then after standard form, if I remember when I was solving inequalities, I then factorize. P squared minus 9 is the difference of 2 squared, that's p and p. Square root of p squared, square root of 9 is 3 and 3. I then know that the signs need to be different, positive and negative. Then next step, I write down the critical values. P is equal to -3 or P is equal to +3. Those are my critical values. Then graphical representation. -3, smallest critical value, biggest critical value. Okay. And then from yesterday's live lesson, I mentioned that when we have less than 0, that simply means less than 0 means negative for y. That's when y is negative. All right. And that means below the what? The x-axis, in other words. Below the x-axis. Below the x-axis. Right? Yeah. It means y is negative. Where y is negative, we know that y is negative below the x-axis. So that means that's here. That means when we write our answer, we're going to say -3, P in the middle, -3 on one side, 3 on the other side. We're going to say less than, and that's basically our values of P. The values of P that will basically allow me to have non-real roots. It's when P is greater than -3 but less than 3. Finished. And I followed the same method that I know to follow whenever I'm solving a quadratic inequality. Okay, guys, that basically, I feel like I've given you a meal and a half. That's why, Yengoku, you have the prerogative of knowing what you know now. You go and apply what you know in questions maybe that are in your textbook, in past question papers. You can go and look at past questions and exams, and then you can attempt them. There's also type 3 of nature of roots, but I have provided examples of type 3. I recently uploaded a video on type 3 of nature of roots on my TikTok page, yesterday. So you can check out the video, because those are questions that have to do with show that or prove that the nature of roots are a certain way. Okay, and basically you are given an equation, and the way that you go about it basically is you go about it the same way as discuss or determine the nature of roots with those types of questions. But I've done an example in one of the videos. You can go and check it out, and that basically sums up nature of roots in a nutshell. Okay, also, if you'd like to get a little bit more enrichment and learning and understanding with nature of roots, I have done part 1, part 2 and part 3 of nature of roots. You can go to my YouTube channel. There on the grade 11 playlist, I have basically done 3 live lessons where I've actually done I've answered and I've basically done the 3 types, doing a variety of examples, so that you can kind of get a bit of depth when it comes to nature of roots. You're more than welcome to jump onto that platform and go and check it out. My link, obviously the YouTube link, is in my bio. It's also called Maths is a Game 5 to 7. You can just check it out. You can go on there. Please subscribe. I'd really appreciate the subscriptions. The YouTube channel is still in its infancy. You can always check that out. Okay. Yeah. I don't know if there's any grade 11s that are like trick. I saw someone saying solve was it general solution or solve for an unknown, do trigonometry and trig equations. Is that person still there? Tsepang, you're welcome. I'm glad I could help you with your nature of roots. Yeah, please also just go and check out what I said. It will be very helpful. Okay, you go and check it out. The 3-part, I did a 3-part sort of like lesson on nature of roots, where I did the discuss or determine the nature of roots, where you saw, and I did a variety of examples and just explained a little bit more in depth. So it's part 1. Then you can check out part 2, which is on what I just did now, for which values. And then part 3 is where I do only the show that or prove that type questions with nature of roots. And I also show you how to how basically all of this can also be represented graphically. Like when you look at a sketch, a parabola on a Cartesian plane, you can see when a graph is basically representing a nature of roots that shows that the roots are real and unequal. Or when the roots are non-real, how does the graph look like? Or when the roots are equal, how does the graph look like? So you can check that out too. I think you would definitely get a lot from that. I don't know if there's any other pressing question. You're welcome, Tisha. Hey, Mem was here. It's so cool. That's just a beautiful colleague there, Miss Krina there. An amazing colleague there. One of the greatest science teachers, tutors, sort of like expertise in the area where I stay. Doing some phenomenal things and just a phenomenal person altogether. Don't know if there's anything else, guys. Anything else that's burning in the heart? Or you guys are ready to be left alone? And you guys need to sleep as well. Wake up tomorrow morning. Tests are upon you. Some of you, I'm sure, are writing. Some of you are in the process of writing other tests and controlled tests. Some of you are probably burning the midnight oil already. Need help with trigonometric equations. Is that for grade 11, anyway? Okay, I'm going to do a few trigonometric equations, and then I am going to definitely call it a night. Let me see if I can't get my calculator, unless you are going to help me out and do my calculator exercises there. Okay, let me do a few. For sine, let's say of theta minus 20 degrees is equal to negative 1,243. Okay, let's look at something that they refer to here as determine the general solution. Okay, maybe what I need to do is I need to start from simple and basic, and then I can take it up one ring at a time of complexity, because I think I'm gonna jump from one thing. Let's start from simple then. Sine theta is equal to half. Let's start here. Okay, if we start from simple, then we can make it a bit more complicated as we go along. Okay, and then I can kind of touch on certain things. All right, or maybe let me just end this live and restart it, because I don't want to. I think I want to. I'll tell you my YouTube username. Just go to my bio. Okay, go to my bio. It's called Maths is a Game as well. But go to my bio. The link is there. There are two links on my bio. There's the WhatsApp channel. Don't mind the WhatsApp channel. It's so underused. I haven't used it in a while, and I don't upload much there. There's just past grade 8 and 9 papers and other documents and other exercises, but it's not really been actively used. So you go to the link that has my YouTube channel. You click on that, it should send you to my YouTube link. Please then subscribe, that would be great. And then, like I said, you can go to my grade 11 playlist. There's a playlist there for the grade 11s. Yeah, everything that I've done for the grade 11s on the YouTube lives, TikTok lives is there. And you can just check out, the 3-part nature of roots that I've done. Okay. I want to end this live, guys. I'll come back on because I want to save this video and